In case of total FADEC electrical power loss, the engine will likely shut down or run uncontrolled depending on design. Internal engine air system functions include cooling, sealing, and bearing sump pressurization. Bleed air used for cabin pressurization is taken from intermediate or high pressure compressor stages. Excessive use of bleed air for anti-ice in systems leads to reduced available thrust and possible higher turbine temperature. Engine cowl anti-ice systems usually heat the intake lip using hot bleed air. A typical indication of a bleed air duct crack in the nacelle is hot spot and possible nacelle overheat warning. Cooling air for turbine blades must be high pressure compressor air routed through internal passages. Buffer air in some seal systems is used to prevent oil leakage by flowing from high pressure air side to low pressure oil side. Engine customer bleed air refers to air used for aircraft systems such as air conditioning and the icing. Continuous operation with nacelle anti-ice selected on at high ambient temperature may result in unnecessary performance loss and higher EGT. If engine internal cooling passages become blocked, local overheating and rapid component damage may occur. The most common engine fire detection system on transport aircraft is continuous loop detectors. A fire loop that detects both overheat and fire conditions uses temperature-sensitive resistive or gas-filled elements. An engine fire bottle usually contains HAON or similar extinguishing agent under pressure. A typical fire bottle discharge is initiated by electrical signal from the fire handle or switch. Pulling an engine fire handle normally closes fuel, hydraulic, and bleed air shutoff valves, and arms the extinguisher. A fire detection loop shorted to ground usually indicates fault in the system that must be identified and corrected. Engine firewalls and nacelle linings are designed to contain or delay the spread of fire. Engine mounts must be designed to carry engine weight and loads, and allow safe breakaway in extreme failure. Flexible fuel and oil lines in the nacelle must be fire resistant or fireproof subject to location and regulations. A typical nacelle overheat detection system senses high skin or duct temperature indicating a leak or hot spot. If mass airflow through a turbojet is increased while jet velocity rise remains constant, thrust will increase. The compressor pressure ratio is defined as outlet total pressure, inlet total pressure. For a given engine, if compressor efficiency falls due to blade damage, fuel flow for the same thrust will increase. A free turbine turboshaft engine has the power turbine not mechanically coupled to the compressor. A simple way to reduce EGT during takeoff on a hot day is use the rated or assumed temperature takeoff thrust settings. For a constant RPM gas turbine, if ambient temperature decreases, the corrected speed increases, because actual N for the same corrected speed is lower. The hot section of a gas turbine engine refers mainly to combustor, turbine, and exhaust. A primary reason multiple bearing chambers are used along the shaft is to support rotors in separate lubrication zones. During engine shutdown, motoring is sometimes used to cool the engine and clear unburnt fuel after an abnormal start.